Good morning, everyone. We are the group 4, Sikia, Grana, and Gunela. And our topic for today is the marine magnetic compass. Our first outcome is that this lesson will guide the students on how to calculate the deviation, variation, compass error, and true course. Our learning outcome is that at the end of the discussion, the students will understand the technique on how to solve variations, deviations, compass error, and true course. Next slide will be quadratic case.
In solving the deviation, of course. Okay, I will discuss solving the deviation. For example, the given is find the deviation of course 217 degrees. The solution is compass C is equal to 210 and 220. As you all know that 217 degrees is in between 210 and 220. So, buta na mga sagikan ng 210 of 220 is that is from the table of given the table and it has a corresponding deviation in different charges. So in different charts, there are different deviation based on compass errors and in this given, the degrees of compass course of 210 has a deviation of 2 degrees west and the compass course of 220 degrees has a deviation of 3.2 degrees west. So the difference between the two compass courses is 10 degrees, and the difference between two deviation is 1.2 degrees west. So the formula of difference of deviation is equal to the 3 times 1.2 divided by 10 is equal to 3.6. So the division course 217 is equal to 3.2 minus 3.36 is equal to 2.84 degrees west. So why do we minus? Because it is west. So if we should minus if the deviation is to the direction of west. And if the variation is 3 degrees and the deviation is 2 degrees east, in calculating the compass error, is the solution is variation is equal to 3 degrees east and deviation is 2 degrees east, which is from the given in the problem. And to solve the compass error is if the variation and deviation has same same direction like east or west. So we will just add both of them. So 3 plus 2 is equal to 5 degrees. So it is given, as you can see in the graph in the right side, the compass error is from the true north to the compass north. So that is the summation of variation and deviation. And if the variation is 4 degrees west and the deviation is 2 degrees east, calculate the compass error. The solution is variation is equal to 4 degrees west, deviation is 2 degrees east. The compass error formula is summation of variation plus deviation. But since our variation is in the direction of west, so we will need to subtract and the direction east is addition. So the difference between them is 2 degrees west since the negative 4 minus 2 plus 2 is equal to negative 2. And negative 2 degrees is in the direction of west. So the answer is compass error is equal to 2 degrees west. If the compass bearing is 0.52 degrees compass course, variation is equal to 4 degrees west and the deviation is equal to 1 degrees east. Calculate through bearing solution. Variation is equal to 4 degrees west and 1 degrees east. Compass error is equal to 3 degrees west. So we just minus the 1 degrees east from the 4 degrees west and the answer is 3 degrees west. And in computing the true bearing, compass bearing is equal to 0.2 as it is given from the problem, and the answer of our compass error is equal to 3 degrees west. So we just minus, since it is west, minus from the compass bearing, and the true bearing of our course is 0.49 degrees. And if the compass bearing is 0 to 8 degrees compass, and the true bearing is 0 to 5 degrees true, find the compass error. In solving the compass error, the solution is true bearing is equal to 0 to 5 degrees true, and compass bearing is 0 to 8 degrees compass, and the solution is true true course minus the compass bearing, and the result will be the compass error. And the compass error between the 0 to 5 degrees true and 0 to 8 degrees compass is equal to 003 degrees west. So note, if compass is less than the true, the error is east, and if the compass is greater than the true, it is west. So since the compass bearing is greater than the true bearing, then it is expected that the compass error is equal to 003 degrees, and it should be west since compass is greater than the true course. Division of ship specific error due to onboard magnetic influences, magnetic items to which magnets are attracted, wires carrying DC or electrical current induce effect ship specific error due to onboard magnetic influences like magnetic items. So if the compass is is placed near and magnified items, so it will cause a chip specific error, which as you all know that the needle in the compass will detect the magnetic field. So if you place magnetic items near them, so it will cause the error in the needle. And also, while carrying DC current, a magnetic field, which can cause the compass to become erroneous due to the flow of magnetic field in the electrical current, and it can cause the needle to point in such a way that the magnetic field is directed to the compass. So it will reduce the integrity of the compass in pointing the magnetic north. So this is a example of a compass cross, which the star is the true north, and the parallel latitude is the so error due to 015 degrees is west variation. Additional error due to, so if the error is from west, so if the compass is pointing to north, you just move 15 degrees west since it is the variation, and the additional error is the deviation. Measuring the deviation by yourself. Using deviation table we can obtain the deviation value of a specific compass course. First, you have to know how to do so. And the next quarter will be that the error.
Compensation. Deviation of greater than 10 degrees. Special magnet which is compensated involving most compasses can be and can still have significant deviation. So, ang arrangement, special magnet helps to boost the and most compasses are magnet boxes with instructions, and it can have computation error after computation. Computing for calculation. So we already know T is in DC, which is T is a true string. The 00 consists of then the V is the evolution of the chart, the Y is the magnetic field, the D is the so this chart is the equality chart, and this chart contains the main field geomagnetism. So this chart, you can see there the distance of inclination, and if the inclination on the earth is positive, so you can see there the different fields with applied solving, the observatory unrolling, and the circular variation solving. And this magnetic inclination model is in 1995. Swinging shifts. It is a process of measuring the total deviation error after compensation. So, ang swinging shift kay mag-1 after the compensation. And it's usually determined in 15 degrees minus 30 degrees heading increment. And recorded in form of deviation table, compass adjuster can provide one or you can do it yourself. So, ang swinging shift kay hindi siya mabuhat sa not measuring deviation. So for each 15 degrees minus 30 degrees, you need to know exactly what direction the magnetic field both is pointed. So you really need to know where's your direction and compare with compass reading and so that you can compute the deviation. And this puzzle is what you know the key to puzzle. And key to puzzle is knowing exactly what direction you're headed. So it is really important to know our heading direction by the key to puzzle, and there are several ways. So this illustration is the charted object within 6 miles distance. So in calm water with minimal current, remaining in vicinity of atom record both compass heading and relative bearing every 15 degrees and 30 degrees. Compute division for each heading. So lately, Cadet Technikia uh, explain how to compute the deviation. So by this illustration and the computation of the deviation, we can get our deviation by this by the I mean the formula of deviation. Measuring relative bearings. Mounted parallel to metal keel with all around views, 0 degrees aligned with aligned targets in size with relative bearing on scale. So this is measuring relative bearing kan kita na po nga illustration with the example of measuring relative bearings mo sa ang equipment to use to target the align target in size and relative bearing on scale. Electronic steering compass. So this is the example of the electronic steering compass which features automated division elimination. So na-feature na nadaan nila ang division elimination so there is electronic steering compass. And the next tutorial will be to this one.
So local magnetic disturbances. So these compass can seem wrong. In some locations, there are local magnetic disturbances that can affect your compass, often noted on the chart. Next slide. So shipboard compasses. Precision axis of this diagram. These are the identification of the shipboard compasses. So speed axis and torque axis. The gyro compass has three axes: the speed axis, the torque axis, and the precision axis. As centrifugal force on the Earth's rotation or tangential velocity act upon the gyro, the torque and precision axis will react and keep the speed axis rotated perpendicular to the plane. Now, the next slide please. So in shipboard compasses, the gyro compass. The gyro compass has several advantages over the magnetic compasses. So these are the advantages over the magnetic compasses. First, it seeks through a orographic meridian instead of magnetic meridian. Second, can be used near the Earth's magnetic poles where the magnetic compass is useless. It is not affected by surrounding material, and the fourth is its signal can be fed into inertial navigation system, automatic steering system, and fire control system. So those are the advantages of gyro compass over magnetic compass. So being a complicated electronic instrument, the gyro compass has some of these advantages. So these are the disadvantages of the compass. First, it requires a constant source of electrical power and is sensitive to power fluctuation. So second, it requires periodic maintenance or qualified operation. So those are the disadvantages of the compass. So methods of determining the compass are although the gyro compass is a very accurate instrument and normally has a very small error, associated with its review less than 1 degree, point 1 to point 2 degrees. The indicator is required to error base once a day. Zero compass error, magnetic compass error. This issue indicates this request. So shipboard compasses. If the zero compass bearing is higher than the actual bearing, the error is less. So in this statement, it is we determine that if the zero bearing is higher than the actual bearing, the error is less. So the second, if the zero compass bearing is lower than the actual bearing, the error is least. So this is opposite of the first statement. So let's let this. And that for the chapter 3.